All right, welcome back. We have the rational class that we've been working on, and we wrote the add method, and I asked you to come up with the subtract method. Hopefully you realize the subtract, multiply, and divide, that is. Hopefully you realize that the subtract method is really no different than the add. The only minor change is the minus instead of a plus. The multiply, when you multiply fractions, you multiply across the top, you multiply across the bottom. And that's pretty simple. Get denominator times get other dot get denominator, and get numerator times other dot get numerator. The divide, though, is actually reversed. So when you divide two fractions, if I have 7/3 divided by 3/4, what that ends up being is 7/3 times 4/3. We end up flipping this fraction and multiplying by the new one. And then you do top times top and bottom times bottom. So the result to this division is actually 28/9, which I have shown here by making get denominator times other dot get numerator and get numerator times other dot get denominator. All right, and then I return a new rational. So let's play around with it. All right, I'm gonna make a rational number. I'll set new rational. I'll say 1/3, and I'll make another rational. Let's call it 2/5. Let's go ahead. You see, we got all these methods here that we inherited, right? But we also have some additional methods here dealing just with rationals. So if I wanted to, I can still do real addition, and I can give another rational, but then it's going to give me a decimal, right? But if I want to do if I want to do rational addition, I have to choose that. And then it's going to get me, 11/15. Let's get it and call its two-string. I want to make sure we see how that works. There's its two-string. You see it's a fraction. Okay, so that's pretty good. Let's try multiplying. So I'll say this number multiplied that number. Get. And we'll do two-string. 2/15. Pretty neat. All right, let's see how this would work out if we were coding it, right? Without having to use the workbench. I'll make a number, rational A equals new rational. And I'm going to say 3/4. Okay. And I'll say rational B equals new rational. And I'll just say 1/2. Oh, I misspelled rational. Okay, so now what we can do is let's just print them. System.out.println a.add b. It's going to automatically know that I want to run the fraction one. And 10/8. Oh, wait a minute. That's not good, is it? 10/8 is not reduced, is it? Is it correct, though? If I was to reduce it, it would end up being 5/4. Let's see, is 3/4 plus 1/2 5/4? Well, 1/2 is 2/4. So yeah, it is correct. It's just not reduced. So let's go and fix that. Well, where should the reduction occur? Well, we could do the reducing here in these methods, but I want to reduce it when the user creates it. So right here, before we set these things, I want to reduce my fractions. So what we're going to do is we're going to use the GCD. So that'll be pretty exciting how that works. So let's write the method for GCD. Public int get greatest common divisor. And I'm going to take in two numbers, int A, int B. So to get the greatest common divisor, you're looking for the biggest number that goes into both of these two numbers. And there's a lot of different things we could do. We could use a list, and we could list all the divisors and find the biggest one that they both have in common. That would be certainly one thing we could do. We could guess and check, I guess, would be another way. But what I want to do is I want to use something called Euclid's algorithm. Euclid's algorithm basically goes like this. It says that if you have two numbers, let's take our two numbers. Let's say they're let's say 18 and 12. We could probably look at that and see the GCD is actually 6, right? That's the biggest number that goes into both of them. So what you do first is you see if the remainder, when you divide this by this, is 0. So that's the mod operator. The percent sign is the mod operator. So 18 mod 12. Well, the remainder when I divide 18 by 12, 12 is an 18 one time with the remainder of 6. So because it's not 0, what I do is I change, if I call this A and I call this B, I change what was A to become B, and I change what's B to be that remainder. And then 12 mod 6 is 0. Now that I've gotten 0, I stop this process, and that is the GCD. Let's try it again. Let's say that my A and my B are, I'm going to do 10 and 12. So I do 10 mod 12. Well, 12 does not go into 10 at all. It goes into it 0 times, right? If I was doing 10 on the outside with a 12, 10 in the house, 12 on the outside, 12 goes into 10 0 times. 0 times 12 is 0. And I get a remainder of 10. So anytime you take a number, mod a bigger number, it just gives you that first number back. It does that every time. And then remember the rule, this becomes our new A, and this becomes our new B. So now I have 12 mod 10. And what is 12 mod 10? Well, 10 goes into 12 one time with a remainder of 2. Now this becomes A, and this becomes B. But 10 mod 2 is 0. It goes into it 5 times with no remainder. So because of that, that value is my GCD. So let's see how we code it. I'm going to say int remainder equals A mod B. While remainder does not equal 0. So what do we do when the remainder is not 0? Do you remember? A becomes my new B. B becomes my new A, and the remainder becomes my new B. So do you remember we took what was B and we screwed it over to A, and we took what was the remainder and we put it in B. So A will get B. B will get remainder. Well, when that's all said and done, remember the B will always be the greatest common divisor. So then I will return B. All right, so how does that help us? Well, now that we know that, we can use it in our constructor. So I'm going to say int divisor equals get GCD. And the way we wrote it, it takes in two numbers. So I give it the numerator and the denominator. I still haven't set these private variables yet. That comes later. Now that I've got the divisor, I will use integer division because I want it to stay an integer. And if it's a divisor, it should go into it evenly. So there shouldn't be any decimals. And there we go. And now we have a reduced fraction every time automatically. Pretty neat, huh? Okay. Let's see. I'm checking my notes here. Is there anything else I want to do? Oh, you know what? I wanted to do, well, you know what? I don't think we need to do get as integer. We could. We have a get as integer here in the real, and it's going to inherit that. So that would be fine. We could say get as integer, and we could override it and just say, does the denominator equal 1? That would also be nice. I don't think we need anything else. Well, we could do an is proper fraction. Let's do that. I'll put it down here at the bottom with my toString. So public, I'm going to return whether or not something is something or something else. Well, I'll say get is. Oh, I'm in the real class. Ah, that's not good, y'all. Go back. Go back to rational. Go back to rational. All right. Put it down here. I'm going to say public Boolean is proper fraction. A proper fraction is one where the numerator is smaller than the denominator. I think I just gave it away, didn't I? What you just want to know is the numerator smaller than the denominator. So I return numerator. Well, let's use our methods. Get numerator less than get denominator. If it's a proper fraction, that will be true. Okay, that pretty much spells out the rational number class. So we are ready to continue. With what, you say? Well, with another number. An integer. There actually is an integer class already built into Java, so please don't get confused by this, but this will be an integer class, only an integer, only in our package. So integer. What's it going to subclass? Public integer extends rational. An integer is one where you have no fractional part. An integer is a rational number, a fraction where the denominator is 1. Once again, I forgot the word class. There we go. So what it's going to have one value. It's going to have the only thing it's going to store is the integer part. Well, it's really just a rational. It's just a get numerator. So I'm going to try and save memory here. Okay. So I'm going to say I don't know if it actually saves memory, but I'm going to save typing. Public integer, and it's going to take in an int value. And I need to call the super constructor. I'm going to get an error, right? What's it say? Class rational cannot be applied to given types. It's requiring an int and an int. What did it find? No arguments. Why? Because this is there right now. Well, what's the numerator going to be? Well, if I had, let's look here. If I had a fraction, a whole number 7, what is that as a fraction? Well, it's 7 over 1. So my numerator is the value, whatever that is, and my denominator is the number 1. Let's override the get value method. Public void, no, not void, int get value. And I'm going to return get numerator. So get numerator is in the super class of rational, but it's inherited. Cannot override get value in real. Return type int is not compatible with double. Oh, okay. We already have a method called get value, and that's not going to work because it's got a different return type. Well, you know what? That's okay. So let's not do that. Let's call that get integer value. There we go. Now it'll like it. I was wondering about that. Okay, so we've already got so many things. We can add things together. We can subtract, but they all are going to return rationals now. So let's take a look at how that's going to work. So integer a equals new integer 5. Integer b equals new integer 7. A dot add b, and it's a rational, and you'll see what happens. Look what it's got. It's got a value, it's got a denominator, it's got a numerator, and when I try and run this toString, I want to bring it over. Hold on. Now, if I try and print this or run its toString, look what I end up getting. I end up getting 12 over 1. That's kind of lame, right? Well, we can override the toString in the integer class, We could also make it to where the rational class will not print over 1 using an if statement in the rational class. I'm just going to go ahead and override toString here. I'm going to say public string toString, and I'll say return get numerator plus quote, quote. So that's going to make that a little better, but it's not going to fix the issue we just had, because you'll notice that was a rational that I had. Look at that. Rational was what I brought in. So it's still a problem. It's not going to fix this at all. I think it's lost it because I recompiled. I probably lost that info. We're going in order to make it return an integer, we're going to have to override add, subtract, multiply, and divide, but just for integers. And so I'm going to ask that you do that right now. So if you would please pause the video and add and write those methods: add, subtract, multiply, and divide. Okay, let's see how you did. Here's my methods for subtract, multiply, and divide, but there's one that we need to talk about. We need to talk about divide. That division there, that could result in a non-integer number. If you add 2 integers, you get an integer. You subtract 2 integers, you get an integer. You multiply 2 integers, you get an integer. You divide 2 integers, no, you get a rational or an integer, depending. So we're going to go ahead and stick with integer division. So if you try and divide an integer by an integer, then it will result in an integer. If you want it to be an integer, if you want to not get integer division, you're going to have to make it a rational and use rational division. We've seen that already with the primitives. So to me, that makes a lot of sense. The last things I want to do to make integers more interesting is I would really like us to add some functionality to some of things like getting factors, getting GCD, getting LCM, getting whether or not it's prime, and getting whether or not it is even. So let's do that. Let's add some methods, because we're really going to make the integer an interesting class. So I'm going to return a list of my factors. So I'm going to say import java.util.list. But because we're having to create the list ourselves, we actually need to have something else. I'm going to say import java.util.ArrayList. So an array list is a type of list. List is actually what we call abstract. You can't actually create a list. You can have a list, you can get a list, but you can't make it yourself. You have to choose one of the concrete versions, like abstract, like array list. And that'll make more sense later, but that's just the way it is. So public list, and it's going to be a list of type integer, and it's going to be called, we're going to say get factors. So what I want this to do is I want it to list all of the factors that are all the integers that can evenly divide this number. And since we don't know how many that is, like the number 8 has quite a few, but 7 only has 1 and 7. We don't know what that is. So we don't know how big it is. So I can't just use an array. I need to use a list. And a list allows you to add and add and add and add and add. And you don't have to know how many you're going to have. You make an array, you have to say, okay, I want this array to be of size 5, and that's exactly all you can do. So here's what we're going to do. We're going to make a list first of all. Remember, I said you have to make so we're going to make an array list, and I'm going to put integer. I'll call it factors, and I say new array list integer, open close parentheses. So it's pretty confusing, I know. So I could actually just call this a list. I don't have to put the word array list in front of it. I just usually do. I'm returning something of type list, but you can't say new list. It'll give you an error. It'll say you can't do this. It's abstract. Is abstract. See, and we'll talk a lot more about that later. But you have to use something array list, okay? And so I can call this one, when I type it, it could be list or array list. Doesn't matter. It'll work either way. So I've got an empty list. I'm going to add to it all the things to divide. So I'm going to say for int I equals 1, I less than get integer value I plus plus. Ooh, I'm going to say less than or equal because I want to include the number itself. I'm going to ask a question. If get integer value when divided by I has no remainder, how do I get that? That's mod. Mod I, if that has no remainder, if it equals 0, two equal signs, then I'm going to add it to my list. I'm going to say factors.add. But here's the thing. I'm making my factors of type integer. So I need to say new integer I. And that's because if I'm going to give my list of factors, I want it to have all the fun stuff that I have with my other stuff. I don't want to return primitives. That's why we're doing this, right? To have all these cool things that we can do. So I'm going to add them to my factors. Then when I'm all done, I'll return my factors. Oh, could be called factors. And get integer value is a method. Ugh, forgot my parentheses. Okay. So that looks pretty good. Let's try it out. I'm going to make an integer, and I'm going to call this 12. And I'm going to say, actually, you know what? I can just run over here. I'm going to say system.out.println integer1 dot get factors. That's what we call it. 1, 2, 3, 4, 6, and 12 are all the numbers that multiply that can divide into 12. Pretty cool, huh? All right. Let's get the GCD. Public integer get the greatest common divisor between this integer and some other integer. Well, we kind of already have this method, don't we? We wrote it in rational. We have get GCD. It takes in two primitive ints and returns for GCD. So I'm going to do that. I'm going to say int GCD equals get GCD get integer value, comma other dot get integer. So a little bit confusing. It's got the same name, but this is where this one only takes one parameter, so there's no confusion. When I say get GCD here, I'm going to use the one that takes two parameters that comes from the rational class, and they took int, so I have to send it integer values. And now that I've got that, then I can return a new integer with that GCD value. Okay, let's check it. As you should notice in the notes, I forgot one thing. I forgot to recalculate my remainder, so I need to do that before I check it. So make sure your get GCD in the rational class has that remain. You got to redo it every time. It would be bad not to. So, all right. That being said, let's make a new integer. I got to compile again. Let's make a new integer. I'll do 24, and I'll do 36. And now I can check out my get GCD between this integer and that integer. And let's get it. And I will check its toString. Boom, 12. It works. All right, next, let's do the least common multiple. The least common multiple is actually got a really cool formula. You just simply multiply the two numbers together and divide by their GCD. The GCD will always go into either of those two numbers because it is the biggest common divisor. So you simply multiply the two numbers together and divide by the GCD. The least common multiple, remember, is the smallest number that both numbers would go into. So for example, the GCD of 8 and 6 would be, 24, right? 24 is divided by 8 is 3, and 24 divided by 6 is 4. So it's that kind of thing. See, public integer, get least common multiple between this integer and some other integer. And I can do that by saying return, I'm going to say multiply this. So remember, there's an implied this here. Multiply this integer by the other integer, then divide by the get GCD of that other integer. Now that is probably a little confusing because I'm doing a lot on one line, but I wanted to show you that I could do it. You probably would want to think of it like this. So remember the GCD, sorry, the LCM is the product of the two numbers divided by their GCD. So I'll say integer prod equals multiply. We've already got that method, right? And then I'll say integer LCM equals prod dot divide. Let's get their GCD. Let's say integer GCD equals get GCD with the other, and then I think we don't need to do. Well, we can. We'll do one more line. Integer LCM equals the product dot divide by GCD, and then we can just return that. So, and we're dealing all with this cool integer class that we've made. It's super neat. Why don't we make another method called isEven? And I also want to do one called isPrime. So that'll be our last two. We're going to say public, what am I going to return if I am telling you whether or not something is even? It's going to be a Boolean. Is even. And I'm going to simply just return whether or not this integer value mod 2 has no remainder. That'll tell you if it's even. How can I tell if something's prime? Well, what are the factors of a prime number? Like 7 is a prime number. The only numbers that divide 7 are 1 in itself. 13, the only numbers that divide 13 are 1 in itself. So in other words, the list of factors will always be a size 2. So we've got a get factors list. Let's just ask if that's a size 2. Public Boolean is prime. We'll just say we're going to return true or false. Get factors, that's a list. Get factors returns a list. And dot size will tell me that size. Does it equal 2? If it does, then we're done. Then we know that it's prime. So let's make an integer. 137. Is it even? It is not. Is it prime? It is prime. Right. Let's do another one. New integer 139. Are you prime? You're also prime. Let's do another one. 141. One of these numbers isn't going to be prime, right? Is prime. False. It must have some divisors. Let's get them. Let's get the, where are they? Get factors. Returns a list. Let's inspect it. Oh. I'll just get it, actually. List. Oof. Lots of stuff in a list. Okay. I don't want to do that. Right now. System.out.println array lists 1. There they are. 1, 3. So 47 goes into it 3 times, apparently. So I hope you think this is cool. Like, it's a pretty advanced math package. We could add more. We could add algebra classes and things like that. I love to incorporate math and computer science because they're really tied at the hip, and it's a good way to understand the structure of it. Okay, before we quit though, I want to talk about testing and doing this in code. So let's make a new class and let's just call it test. And in this test class, we'll call it public class test. I know I'm pushing you right now. I'm actually going to introduce, I've been talking about it, I am going to introduce static here, but not quite yet. Just 1 minute. I'm going to say public void run. And so I'm simply making a method that it run. This is most applications have many classes, most of which are not runnable. But once you have a runnable one, they're the ones that control the processing of all that information that we made. So we're just going to practice making some variables. So I want to talk about, let's make a real number. Real a equals new real, and it takes like a double, 5.6. Let's make another real. Negative 1.3. Let's make a rational. How about 1 and 6? Um, 3 and 2. Let's make an integer. So again, I type it. I have to type it, then I give it a variable name. I got C twice. Integer CD. How about integer E? I'm just going down the alphabet. These are my variable names here, y'all. A, B, C, D. These are my... So on the left here, these are the types, and they typically will match what it is I call new on. Okay, and then I'll say new integer 7. Integer F equals new integer 12. All right, so I'm just going to do some printing and see if we can't figure some stuff out. I'm going to do a.add b. System.out.println a.add. Can I add C? Can I add a real and a rational? Sure. It'll do rational addition now. Let's try C.add D. That's rational. Let's type C as a real. So I have to put it in parentheses like that. So I'm typing it as a real. Then I'll say .add D. So that's a little unusual, right? But we'll see what that does. I want you to see that. Okay, and then I'm going to say system.out.println. I'll say f.add e, and I think one more time. Let's do system.out.println f.get factors. So we can just kind of see how all this is working. Compile. And now, instead of having to recreate everything, I've got a nice test class. I just create a test, bring it here, and now I run the run method. And we can see everything gets printed out. And so I did want to point just a couple of things out here. So we need to be able to link up each one of these things to it. Okay. So we see 4.3 is the adding of 5.6 and negative 1.3. The rational number, let's see here, A and C, that's adding a real and a rational, so that's a decimal, right? A add C, 1/6 plus 3/2 is apparently 5/3. We'll have to do that math, right? 2 plus 18 is 20 over 12 is, yeah, 5/3. So yeah, that's right. But now look what I did. I cast C as a real and then added it to D. And what happened? Well, I get 5/3 as a decimal, right? So, and we can always run get value when we add to just get their value as a real number. We left that method intact, so we always inherit that. So I could have done it that way, but that just, by casting it as a real, I force it to return a real. We just simply added 7 and 12, and then finally we ran the factors of 12. So that's how you can do all that. But did you notice what I had to do? I had to create an instance of test and then run the run method. If I say the word static right here, public static void run, what that allows me to do is run the method on the class, not an object. So now when I right click, you'll notice that I can make a new test, but I can also just immediately run void run. So That's your first introduction to static. What does it allow you to do? Write a method and call it directly without having to bring it to your workbench. The way that you run it is like this. You say test.run. You put the name of the class, and you'll notice that, well, somewhere it ran it. I've lost my terminal. There you see that it ran it right here. So I know it's a nice long lesson. I hope you enjoyed that. I hope you got a lot out of it. We're covering lots of ground here. We're going to dive back into some more Greenfoot and use lists and use subclassing and calling methods on different objects. So here we go. Saddle up.